So today we're going to talk about the email vulnerability called email injection. It's a vulnerability that might seem to have little impact at first glance, and in bug bounty programs, it usually gets you a P5 or P4, meaning it's considered either informational or low. But today I want to share some tips with you so you can learn how to escalate this vulnerability and get good bounties from it. These are the average bounties that students of pentesters have received. Every year, during these months, the Pentest Academy has earned between $500 to $1,000 from email shell injection, with the highest amount belonging to myself at €1,000, and the rest of the students have received amounts like $750, $550, and other cases. First of all, what is this vulnerability? Look, email shell injection means that when a company is sending an email to our user, what can we do? We can influence the content of that email and inject HTML code into it. Keep this in mind. Email providers, the service providers active in the email field, allow the sender to include HTML tags. For example, imagine you're on the Target.com website and you're registering an account there. You go to the first name field. Here I am. For example, in the first name section, when you're signing up, you enter something like this, say Reza. For instance, an image SRC, something like that. Now, in the SRC attribute, you put the webhook address, the collaborator address, or even your own domain. For example, attacker.com and email, or anything else. Now you put in some data so that when a request comes your way, you can tell, since you might use this first name for several different emails. Then, for example, you enter your email. For instance, victim@victim.com. Pay attention. Suppose somewhere a registration like this is happening, and when the registration is completed, an email is sent to this victim. For example, it says, "Hello, user so-and-so." For instance, hello. It puts my first name here. But notice, when it puts my first name, the part where the HTML is inserted actually shows up there like an image that failed to load or is broken. What does that mean? It means that when, for example, an email is sent from support.target.com for registration verification, they haven't sanitized it so that the first name isn't sent in raw form through the email and gets sanitized. What happens as a result? If the victim user opens that email, this image will try to load on their end, and what happens is that a request gets sent to the attacker's domain. Now, for example, we can also put their email here. Imagine a scenario where I, as the attacker, try this with hundreds of people. I want to see which one of those hundreds of people has opened my email. The concept of mail tracking is one of the important concepts that also happens in red teaming. That is, sometimes attackers monitor a lot of people from a company and want to see whether these people open the emails sent to them or not. They use this concept. The guys send an email. They put this kind of content in it, and when that email is opened, basically a request is sent to the attacker's domain, and the attacker realizes, for example, that a user like Reza Sharizada is checking and looking at the emails. Then they go on to use techniques like phishing, HTML smuggling, or anything else to send malware to the user. So the concept is an important one. And the reason why many people in bug bounty don't get results from this concept is because they don't know these things. They don't really understand this vulnerability. They don't give it enough importance. So up to now, we've understood the concept of the vulnerability. Whenever we see that the company, our target, the one we're doing bug bounty on, sends us an email, we try to see what content is in that email. For example, the first name, company name, or anything else, and then we replace that first name and company name with some malicious HTML value. We analyze the email that's sent to us, and then we see whether we can send that email to other users or not. Usually, this happens when inviting users, during registration, or in similar flows. Even when sending a resume, I'll explain later how I was able to easily make €1,000 from this vulnerability. A vulnerability that a lot of people don't even bother to look for. So up to now, we've understood the concept of the vulnerability and realized that it's also used in red teaming. APT groups like APT 28, APT 34, 29, and 41 have used this concept, folks, to send their malware to employees. So up to now, we've understood the concept of vulnerability and learned how to verify which input is vulnerable. First, you need to check whenever you receive an email what the content of that email includes. First name, last name, company name, or anything else. Then see if you can control that content. If you can replace it with an HTML payload. Now remember, the structure of this payload can be HTML encoded, turned into an HTML entity, URL encoded, or anything else. We don't want to make things complicated. 90% of the time, you'll get results with this simple trick. When you see that your malicious payload is loading in your email, now you check to see if you can do the same thing for another user's email or not. If you can, then you have an email HTML injection. Now, how can I increase the impact of my report? First, you can use scenarios like mail tracking, which I mentioned to you. Mail tracking is one of the scenarios that's frequently used in red teaming, and if you can convince the triager, you could easily get a P3. So how can I make it a P2? Like the screenshot I showed you in the Instagram post, where I managed to get 1,000. Now, let's get into the scenario of how I was able to turn an email HTML injection into a €1,000 bounty. An amount that's pretty attractive for a vulnerability like this, which might not seem that valuable at first glance to people who don't have much experience in this field. Look, so far we've figured out that for email HTML injection, you need to look for places where the company sends you an email and see what parameters are included in that email. Then, if those parameters are under your control, go ahead and change them and see what happens. Now, inject your malicious payload in HTML format, and if that HTML is parsed directly in the email. Well, here we have an email HTML injection. The next scenario is to see whether we can send this email to others as well or not, so that we can then report it fully. One important point is that, many times, if you have the skill to chain this vulnerability with another one, you can very elegantly turn it into a vulnerability that gets a P3 or even a P2 impact. In the scenario I reported, I managed to get this vulnerability classified as P2 and received €1,000 for it. So what was the story? In an application, you could register, verify your registration, and then send your resume to different companies. Then, they would check your resume and, if everything was okay, they would approve you. What happens when you send your resume? An email is sent to the email address you registered and verified, saying, user X, for example, is my first name. Your resume has been sent to such and such company. Alright, first point. I come in and, instead of X, I put my own malicious payload. A payload like this, guys, pay attention. URL encoded, HTML encoded, HTML entity. These are different payloads you can put here instead. I don't want to go into all the different ways you can insert a payload. I want to talk in the simplest way possible. I went and put something like this instead of my first name. And yes, I saw it. When it's loading, for example in my Yahoo or Gmail, a request is sent to my VPS server domain, and the email HTML injection is fully present, but so far this vulnerability is self-contained. Why? Because I registered, I verified, and basically this only gets sent to me. Second scenario. Let's try sending this to others. So what did I do? Very simple. When submitting the resume, I added the email parameter. Email, optional email, or anything else you can test as part of the word list, and I saw that yes, a request is also being sent to that email. For example, when I put in second at something.com, that second email is also receiving the same email. What does that mean? It means I was able to perform email header injection for all users. Should I just report this so simply? Absolutely not. I attach this vulnerability to broken access control. I tell the company, I found a broken access control that leads to email header injection for all users. That broken access control undermines integrity based on CBSS, and the email header injection undermines confidentiality. Look, email header injection is the same vulnerability, just presented differently. And this different presentation is exactly why people are getting $550, $750, even $1,000 for this vulnerability. The skill of mastering CBSS, the art of creating impact, is something that's neither unethical, nor problematic, nor anything else. It's all about your experience. I've always tried to share this experience with the students in the Pentheus Lander academic mentoring, and in this video, I tried to keep it really simple. First, let's get to know a vulnerability together, analyze it, talk about its applications in APT for the team, and alongside that, go through a very simple and common scenario. I've tried out this resume scenario 3 or 4 times. On average, I receive between 700 to 1,000 euros, with the highest being 1,000 euros. And remember, in all of them, we only had a simple HTML injection email, nothing more. But by creating a scenario, we managed to get the highest payout. I hope you enjoyed it. If you've made it this far, don't forget to like, subscribe, and share. I'd be happy to see you in the next videos.